Hey grade 10s. All right, so as promised, I need to do a section 4.3 video lesson. It's a short one, and this topic starts with talking about the internal combustion engine, so you can read about that in the textbook. So it's internal combustion means that the actual combustion happens inside the cylinder, which was not true of the steam engines, correct? The combustion of the wood or whatever the fuel was to generate steam was done outside of the cylinder, and then the steam would go into the cylinder. But in a modern internal combustion engine, the actual combustion, the burning, happens within the cylinder itself. So we're going to take a look first at a typical cylinder of an internal combustion engine, and it goes through 4 separate stages. So each cylinder, each piston in each cylinder goes through 4 separate stages. So you're going to have to know the names of those strokes. So let's look at the first stroke. The first stroke is called the intake stroke, and this is where the piston will be moving down. And you can see up top here in the cylinder we have these valves. We have an intake valve and an exhaust valve. So during the intake stroke, as the piston moves down, it creates a vacuum which pulls fuel-air mixture in through one of the valves. Then the piston is going to be moved up, and it compresses the gases, that fuel-air mixture. So it's called the compression stroke. And at the very top, we have a spark plug here. So there's a timing, a timer that times a spark to ignite the gases in the cylinder. This explosion causes the piston to move down. Now, this is called the power stroke because it's this action that will drive all the pistons connected together for however many cylinders there are that make up a typical internal combustion engine. And we're going to be looking at a 4-cylinder engine. Okay? Now, the very last stroke that each piston needs to make is an upward movement to push the exhausted gases out through one of the valves at the top. So logically we call it the exhaust stroke. Okay, so every piston, every cylinder has these 4 actions occurring. All right, so what I'm going to do is go to my YouTube here, guys, and so I want to show you this in action, right? So here we have 4 cylinders attached together to make a 4-cylinder engine. But remember that each piston is going to go through those 4 different strokes. And at this present time, once I let this video run, you're going to see the pistons. It's actually going to tell you up here what stroke each piston is going through. I'd really recommend, guys, that you check out 2 or 3 of the video clips of animations of these internal combustion engines to make them make sense, because I'm only showing you a very small part in this video lesson, because you can go and check them out in the classroom for the longer version. Okay, so let's let this run. Okay, let's stop it here for a sec. Whoops. Okay, let's go back. Okay, so let's pause it here because we actually see the title of the stroke that each piston is going through. So remember that here, this piston is going to go through its now they call it induction, but we call it the intake stroke. The piston is going to be moving down and drawing in the fuel-air mixture. This piston is in its power stroke. So it's going to have that explosion of gases happening, which are going to drive this piston downward. And guys, it's called the power stroke because these cylinders are all connected by this rod here, okay, a crankshaft. And so since they're all connected, this force pushes this piston down, which turns the crankshaft, which will in turn make all these other cylinders move under that power. So this cylinder happens to be the driving force right now. This cylinder over here is going through its compression stroke, so it will be moving up to compress the gases at the top. And of course it's going to be awaiting its power stroke. And this last cylinder over here is going through its exhaust stroke, which means the piston is moving up, pushing those exhausted gases out, so that it will then be able to go down and do its intake stroke. So I will let this roll, so you're going to see all the pistons in action. Notice there's our, this is going through a compression, power, intake, and exhaust. But then they switch, right? The piston, the cylinder that was going through its compression stroke is now in its power stroke, because it needs to do those 4 strokes in order. Okay, so there, if we focus on this cylinder, guys, this went through its power stroke. Now it needs to go through its exhaust stroke, so it's moving up to get rid of those gases. The next stroke is going to be an intake stroke for this cylinder. All right, so all the cylinders are kind of doing their 4 strokes, but at any one given time, there's a cylinder undergoing a power stroke to make sure that we're driving all the cylinders. Okay, so I kind of hope that makes sense for you. So you can check out those videos in Google Classroom. Now, the last thing, we go back to the slideshow. The very last thing in this topic, guys, is what are the different ways that we can produce electrical energy? So this harkens back to Science 9. You would have learned about generators. Generators work because they take some form of mechanical energy, some form of motion, and you move a coil of wire in a magnetic field. And the relationship between magnetism and electricity allows electrons to flow in a circuit. So in this case, we can use steam power again. We can generate steam using combustion. The steam can flow through a turbine. So you remember a turbine? We talked about that in 4.1. The steam will rotate the blades of the turbine, which are connected to a coil of wire called the armature in a generator, and then that coil of wire experiencing a magnetic field causes electrons to flow through the circuit. And this is the primary way that we here in Alberta generate our electricity. We use some kind of fossil fuel that we burn to create steam, and then that steam is used in a generator to make electricity for us. But in other parts of Canada and the world, they might use hydroelectric dams, which the dams have created water pressure. And then they allow the water to flow down, and again, you're going to have a turbine, again, connected to a generator. And then also wind power. So we see lots of wind farms, especially in southern Alberta, where the wind is pretty constant. It spins the blades of the essentially giant windmill, which again, the blades are connected to a armature, loop of wire in a magnetic field, so a generator, and we can generate electricity that way. And there you go. So that was really all you guys need to know about 4.3. So happy studying, and I hope you do well on your test.